Hey, welcome back to another episode of Tau Club. So what we're going to be discussing today, an extremely interesting thing that exists out there in the universe. This is going to be one of my most favorite topics. And this is the black hole. So a lot of you may be wondering, what exactly is a black hole? Well, let me tell you. It's not just a dark spot in the universe. Let's just imagine a massive star, right? Over time, it burns out its fuel and can't keep up with its own gravity. So what happens? It collapses in on itself and boom! It explodes as a supernova. Now, some supernovae, which is just a fancy way of saying more than one supernova, can form a black hole. Black hole is a cosmic vacuum cleaner, but much more intense. Its gravity is so strong that not even light can escape. That's why it looks black. But don't worry, black holes aren't out there gobbling up everything in sight. They only pull things that get too close. Now, some of these supernovae, which is the plural of supernova, can result in the star forming a black hole or a singularity. What do I mean by singularity? Do you remember the fabric of space-time that we talked about? When you have this fabric, and when you put an object on the fabric, the entire fabric bends to fit that object, and that is gravity, correct? Well, what happens in a singularity is all the mass in that massive star collapses into a single point. So what does that do? That creates an infinite amount of gravity that's known as a singularity. So what do I mean by this? Just imagine that you have your regular space-time continuum, and just like an infinite mass, so this goes on infinitely, but this is just a diagram for illustration, and this point at the very end of it is called the singularity. So what does this mean, right? It means that its gravitational pull is so strong that anything that tries to come here will immediately be sucked in. Anything will be sucked in. And that goes for light as well. Light is a particle and a wave, right? The photon, the electromagnetic wave. And so when it travels, it can also be sucked in. But light travels so fast, right? But singularity is even stronger than that. Excuse me. Even light cannot escape the singularity, which is why we don't see any light reflected from the black hole, which is why it's black, right? To see something, we need light to hit it and reflect back to our eyes. But since light gets absorbed, there's no light reflecting back to us, which is why it's completely invisible to us, which is why we call it a black hole. Okay. Let me just draw a black hole like this. Usually a black hole, it will have a singularity in the center, but you can never see the singularity, right? It's a singularity is surrounded by what is called an event horizon, right? When we look at or try to see black holes, all we can see is the event horizon. No one has ever seen the singularity. If you want to see the singularity, you'll probably die. Very grim, but yes. Surrounding the black hole, let's say the black hole is eating up a star, right? So you have a star here, and it's has such a gravity that it's pulling the matter from the star. So let's say this is all stuff from the star that's coming off of the star and getting eaten. All of this stuff will begin to swirl around the black hole in what is called an accretion disk. An accretion disk. Right, so that's just a bunch of bright matter that just swarming around this dark area until eventually the matter closest enters the black hole like this. And so this is one of the unique properties of black hole. Black hole's accretion disk can be extremely bright, right? But the black hole itself is dark. That's one of the interesting properties. So you can think of the singularity. Let's say you have three dimensions, right? This is a XYZ plane. Let's say you have these three dimensions. The singularity can be seen as a single point, right? A point that exists in all three dimensions, right? It has some x value, some y value, and some z value as well, right? When black hole starts to spin, its singularity doesn't stay a simple point. No, it transforms into something astonishing, a ring. In three dimensions, this is what scientists call a ringularity. Mind-blowing, right? Imagine a ring made up of insanely dense spinning singularity. This happens in rotating black holes and adds a whole new layer of cosmic wonder. So the next time you look at a ring on your finger, remember, somewhere out there in the depths of space, a black hole is spinning its own cosmic jewelry. Some other interesting facts include that every single galaxy has a supermassive black hole in the middle. The supermassive black hole in the center of our Milky Way galaxy is called Sagittarius A star, right? So our supermassive black hole is called Sagittarius. I don't know if there's two G's or two T's. A star, right? And how did we even figure out that this existed, right? How do we find black holes if we cannot see them? Well, that's the interesting thing. For black holes, the way you observe them is by looking at objects that are orbiting. So let's say you have one star like this, and it's just going around empty space. You don't know what this space is. By using some calculations, you can determine the mass required to keep the star in orbit, and you can figure out that there is indeed a black hole right there. Or there are more interesting things when two bodies are rotating each other, where one of them is a black hole and another can be something else. So they have some fluid rotations in a binary system, but you will not be able to see this, but you can see that it's orbiting with something else. That is also how you find a black hole. So there are many unique cases about black holes, and they're very fun to dive into and see what makes them up, right? I suggest, if you're interested, read some books. Read The Brief History of Time by Stephen Hawking. In one chapter, he goes over his discovery of Hawking radiation, which is a very crucial concept to understanding black holes. I hope you enjoyed this video, and please do continue learning, and have a great day. Thank you.